Find the fifth roots of the complex number 2i. And so we're going to take the exact... Wait a second. There's no plus b. There's no...
Is this what
Thank
you're getting at?
goodness that you wrote that down. I was getting lost.
In standard form, if we want both parts, it's 0 plus 2i, which is...
Oh, I already know what r is.
Yeah, what is it?
2.
That's right, because our point is up here at 90 degrees. Oh, that's helpful, that it's at 90 degrees.
Wow, 90.
Yeah, or...
Pi over 2,
Pi over 2.
perhaps?
So r is 2, because that's how far it is from 0. You can do the Pythagorean theorem on it, and it'll still tell you it's 2, unless you screw up. Theta is pi over 2.
So please don't screw up. Heaven forbid you become a screw-up, which will be what you are if you screw that up. You just called them that.
No, don't put words in my mouth.
N,
it's the fifth root, so n is 5, which means that the values we're going to plug in for k are 0.
Always start at 0
1,
for k.
2, 3, 4.
How many k's do we have there, Mr. Stevenson?
We have 5 numbers
There we
because
go.
it's the fifth root.
Fab-tabulous.
Okay, so our formula says in the nth root of r, so the fifth root of 2 times cosine of, I don't suppose you have the, oh look, you have the formula handy. Pi over 2.
I happen to have the formula right here, so we could, use it if we need.
2 pi k. And then on bottom, we have...
Fiver fever.
Did you say Bieber fever?
No. Fiver fever.
Oh. But...
Why would I have Bieber fever?
I don't know. I was going to be concerned. I'm not going to lie.
Maybe I'll put Bieber fever in our tags on YouTube and see how many hits this video gets.
That's terrible. So we need a common denominator. So that we'll have to times by 2. So that's 4 pi k over 2
over 5.
So
hey, look, the denominators on the top are the same.
Yeah.
That's nice.
Last year when I made this video, I totally messed this part up.
Good thing
I
I'm here to make sure that you don't mess it up.
I remember because when we multiply by 1/5, we get a 10 on the bottom.
10 down there.
So I screwed that up last year. I feel really bad about it.
And you just admitted your mistake on...
Well, I'd already admitted it on YouTube.
Yeah, and
so,
you're going to admit it again? You don't like to admit mistakes.
Hey, everyone makes mistakes. I don't like admitting my mistakes
when
to you because you gloat about it. Okay, if we plug in 0... Okay, if we plug in 0 for k...
You're going to just get pi
right.
over 10.
If we put a 0 here, 4 pi times 0 is 0, so that's pi over 10. I don't know what's happening with
what
this
is
line.
happening? Get that line out of there.
Okay. Pi over 10.
Plus I sine pi over 10. Now, if we do our math correctly, we only need to do one more.
And then we'll just be able to look at the pattern.
Yes.
So let's be careful. K equals 1. That means we have the fifth root of 2. Cosine.
And then you're going to have pi plus 4 pi over 10.
Absolutely. So pi plus 4 pi is 5 pi.
Over 10.
5 pi over 10. That reduces.
I know.
Are we going to leave it as 5 pi over 10?
Well, let's leave it as 5 pi over 10 for just a second, and then we can be uber cool and reduce.
Uber cool and reduce.
Yeah.
Okay.
So how far from pi over 10 to 5 pi over 10, K. Steve?
If you have problems visualizing that, you just would subtract the second minus the first. They are 4 pi over 10 apart.
So we can add 4 pi over 10
and get the rest of these. Yeah. So when k equals 2, we should get the fifth root of 2 cosine 9 pi over 10.
Look, we said it together. Jinx, you owe me a soda.
Okay.
And my daughters like to add a Barbie doll after that when they do that. Jinx, you owe me a soda and a Barbie doll.
That's funny.
Yeah.
Add 4 pi over
10.
10.
13 pi over 10. Wow, that's
just
like a...
don't worry about that I.
It's an eye in the wind there. It's being blown.
K equals 4. That's our last one because it gives us our fifth root.
And 4 plus 13 is 17.
Yep.
17 pi over 10.
Plus I sine.
Now, if you are turning this in as a completed problem, you might just check with your teacher to see. I think for us, we're comfortable with 5 pi over 10 being in there.
Because and partially because of the relationship here that these are a pattern.
Right.
If it wasn't for that, then yeah, definitely simplify. But because and in some ways this is easier to look at because oh look, they're all 4 pi over 10
and look,
apart.
they all kind of slant a little bit further to the
Yeah,
right.
that's me. That's not on purpose.
Okay.
That's me writing. So.
But some teachers like to see reduced fractions in there, in which case this would just be
fine.
pi over 2, and that's not a hard thing to make.
Yeah. Now, also, we could convert these to standard form,
Yeah.
just like we've done anything else, and then we could look at the at those actual points.
Right.
And I mentioned this because it's like, well, normally, like, okay, the cube root of 8, for example, is 2.
Right.
That's a number.
That's a specific one. That's one we can work with.
Yeah.
Like if.
So how did I just get 5 different things whenever I found the 5th root of this?
Well, what this is telling us is that you're going to have to multiply this specific number 5 times to get back to where you started.
Multiplying all of these together gets back to where you started. But it also has to do with if we graph these, like pi over 10 with that radius. So that's a very small amount.
They space themselves out
and then up
perfectly.
Here, and then 9 pi over 10, and then this is tricky 13 pi over 10. And what should happen is it should look like those are all equidistant apart, and that's why we're multiplying the same thing
each time
together 5 times.
Right.
That's the root part of it.
Right.
It's just a
that's
little.
how it works.
It's a little different for complex numbers than what we normally think about.
Right.
So.
Right. It's really interesting.
Yeah.
Yeah. There's no yeah.